All right. So let's quickly look at this testnet explorer and what it's really showing us. So as I said, we are aggregating almost all the Cosmos chains at this point. 51 out of 62 Cosmos chains. So 62 on mainnet, 51 of them we are already aggregating. The 11 that we are not aggregating are the ones where we were hitting a too many edge cases in our circuit design. So with upgraded circuits, eventually we can start supporting them as well at some point of time in future. But all the major tape chains we are pretty much supporting right now. So right now we collect proofs, ZK IBC proofs from these individual chains once every 1 hour and create a aggregate proof, which we call as the super proof. So as you can see, we have aggregated a total of 806 super proofs so far, which we have verified on Ethereum. And the next proof is basically due in less than half an hour. Since we are aggregating 51 chains, the cost that every single chain has to pay is basically 1 by 51. So if you subtract that from 1, you get 98%. So that's why we are able to offer a 98% gas cost reduction for proof verification for ZKIBC. If we just go to the super proof verification contract, so this is the contract where we are submitting all our super proofs. And as you can see, in the last couple of hours, one proof has really come in. So every single one of these transactions is corresponding to a super proof submission. And we have had roughly one super proof come in every single hour, which is in line with what you see over here. If you look at the timestamps, you can see that one proof is coming every hour. We can actually go a little bit deeper into a single proof. So there are quite a few fields to understand here. I'll go through them one by one. So the first one is obviously Ethereum transaction hash. This is the Ethereum transaction on Sepolia that verified the super proof. This total proof verification cost, this is not the proof verification cost, but this is the total cost of the transaction that verified the proof. So this includes a bunch of state updates and a little bit of other overheads as well. Which is total 360K. So one proof verification is roughly 250K gas. And if there's some overhead that's happening here, summing to a total of 360K gas, which is the cost of this super proof submission on Ethereum. But if you look at the second field, this is a little bit more interesting. So as I said, we have 51 chains, and each chain has to pay only its own slice of the super proof verification. So 361K gas divided by 51 is 794 gas. So this is the gas cost that every single chain is paying for their own proof verification. So as you can see, it's $1.23. So from $63, we came down to $1.3, which is a significant reduction. Looking at the rest of these, let's say these particular fields. So basically, these are the fields corresponding to the state transition. So let's say we proved the consensus of Cosmos chain, then the on-chain state, the on-chain like-kind state that we were maintaining for Cosmos on Ethereum got updated from a certain height to the new height, which, if you understand how like-clients work, the proof is essentially validating, attesting all the blocks that came between this block height and that block height. So standard like-client stuff. But if you look at this particular column, this is where things actually get pretty interesting. So this is the individual proving time. And if you notice, there's another entry here, which is called a total proving time. So let's try to understand what that is. So the way we construct our prover infrastructure is that we have a bunch of prover chains that are running in parallel, right? And each of these machines is proving one single chain of Cosmos. So these proving times are corresponding to the proving time for each of these machines that are generating proofs for the chains. So, and if you look at this total proving time, this is the end-to-end proving time for the entire process. Now, as I said, so if you look at the pipeline, there are 3 steps. One is the individual proofs from individual chains getting proven. Then we have the aggregation engine, which is putting all these proofs together to create the aggregate proof. And then you have the final step of Groth-16 induction, where we take the aggregate proof and make it even smaller using Groth16 reduction. So if you look at the parallel proving time, which is 689 seconds, this is the maximum time taken by the parallel proving machines for each of the chains. So if you go through the proof generation time for each of these chains, the maximum of them will be 684. So since these are running in parallel, basically we have to wait for the machine that takes the maximum amount of time to generate the proof. So that's the first entry. Second one is the aggregation, which I just explained. It's the one we're putting everything together. The final step is the Groth16 reduction time. We have a little bit of network latency as well, which is not really represented in this one, but it's like less than a couple of seconds. So it's kind of all right.